So good morning, everyone. So my talk today will be why and why not Lua, and we'll start the discussion with why do we need multiple languages. So if you are going to choose languages, important to know why we have to choose languages. Wouldn't the world be better if everybody uses the same programming language? This is a common argument. A lot of time people start saying, oh, this is the language that will rule the world. Everybody's going to use that language. That happens in periods from time to time, and then people realize, no, we cannot use the same language, but there is always this tension between. And a main point of one programming language is that programming language has very strong network effects. A network effect is something that once a lot of people is using something, there is a lot of pressure for other people to use the same thing. So, for instance, some network effects in programming language that if I should learn the most popular language because it's easier to find a job. On the other hand, I should use the most popular language because it's easier to find programmers, to employ people to work in my company. And I should also use the most popular language because it's easier to find libraries, to find tools, documentation, etc. And the final point, I should use the language I'm already using because it's easier. I don't have to learn another language, and so it's much more comfortable. Well, if we follow those rules, the fact is that we should all be using Fortran until today, because Fortran was the first high-level programming language, was reasonable, well, was very successful at its time, and if network effects were that strong, we should all be settled with Fortran. There will be no new languages, and everybody would live happy forever using Fortran. And why are we not using Fortran? Well, it's a very, very simplified story. Fortran was a kind of domain-specific language at the time because it was very, very focused on scientific computation. At that time, even the hardware was different from scientific computation and for what they called commercial computation. And then they created COBOL. That was a language, another kind of domain-specific language for commercial software. And they created ALGOL, that was a kind of domain-specific language to write algorithms, tree manipulation, and that kind of stuff. And there was some other language, Lisp, etc. And then the question, why do we need multiple languages? Why, again, people don't stop it with Fortran? Or why couldn't we put together all those languages in one language to rule them all? And IBM tried to do that. I think that was 1964. They started with PL1. It was a very, very, very big project from IBM that at that time was kind of ruled the world in computing, was the biggest computer company in the world, and they proposed the first general purpose programming language, a language that should be useful for everything. You could use PL1 for scientific computation, for commercial software, for algorithms, etc. And that language would be perfect and nobody would need any other language. And in the end, I think even today, people still use Fortran, people still use COBOL, and a long time ago, most people stopped using PL1. Why PL1 was not a big success was the problems with PL1. Maybe it was a bad project, only they did it wrong. It could be done better. But the truth is that a programming language is not only a pile of features. You cannot just put together a lot, oh, this is good, put in the language, this is also good, put in the language, and get everything you like put together in the language, and then you are going to have a great language. Why that's not? First, there is what is called the subset fallacy, that the idea that I can only use the part of the language that I like, and the part that I don't like doesn't bother me. I mean, I don't have to worry about that part. I just choose the parts I want, and that's it. The fact is that the features that I do not use do affect me in a lot of different ways. And the fact that the bigger the pile, the better the language, this is not true. For instance, bugs frequently involve parts of the language that we do not understand. It's very common, for instance, you do something wrong, and instead of a syntax error, you just get something different from what you intended. You never learned that part of the language. You thought, oh, either that it's wrong, or it's doing what I thought it should done, but it's doing something completely different because it's using some specific features that you never learned about. So you should know most of the language or all of the language to debug your bugs. Second, when you start codes developed by other people, libraries in particular, you have to know all the features those libraries use. You have to know at least the features they use in the API. We have this problem. I think 2 years ago, we started using Python in the initial courses in computer science. And we tried, oh, okay, we just learn the basics, the basic Python, just lists, assignments, basic control structures, and then, oh, it would be good to use some graphic library, and then you get the graphic library. Oh, there is this very good graphic library, oh, but graphic library is already object-oriented, and it has some attributes and a lot of stuff. So to start using library, the students would have to learn much, much more Python than they already learned. So it's this subset fallacy. It always breaks when you start really using the language and you go out of simple toys and really want to write software. You cannot live in with a small part of the language. Like there is the book, the JavaScript, the good parts. It's a famous book. Yeah, it's this, and the real JavaScript book is this size. And it's a kind of cozy to think that, oh, I should live with the good parts, and I think it's locked, sorry. And I could live with only the good parts, but the truth is that I cannot. I really, if I want to be a professional programmer in JavaScript, I have to get the big book and learn almost everything there. Another point is that compilers and interpreters must support the entire language. And so these extra features that you are not using are making them more expensive, more complex, more buggy, and some frequently, mainly for interpreters, are making the whole language slower. And many features hamper optimization. Some features like exception handling in several languages, for instance, if you use that feature, or even sometimes if you do not use the feature, it hampers some kinds of optimizations. So you get slower code even if you don't use the feature, just because the language offers that feature. And maybe the most important point that a lot of people forget is that some of the main benefits offered by a programming language is what it doesn't allow you to do whatever you want. So for instance, Stack Overflows is a big example. Everybody C is a great language. I can do whatever I want with C, but it's a very, very dangerous language, and there is several other languages that give you for free a guarantee that you are not to get a Stack Overflow. And memory safety is another very important point. It's very, very hard to debug memory bugs, and a lot of programs that use C or C++ do have memory bugs. And if the only way to avoid that with a language, if the language really forbids you to do some stuff. It's not, oh, I just put some unsecure my symbol in code and then I open the can of worms and then I can do everything I want. That breaks all promises, that breaks the security of your code. The only way to really ensure security if the language really forbids you to do some stuff. And so in the end, what we have is that the design of languages involves a lot of trade-offs. We have to choose between performance or security or flexibility or easy of use, and we have to choose easy of use for whom, for professional programmers or for end user programmers, what kind of programmers we want to focus our language, what kind of hardware. Some languages are better for smaller hardware, some languages are better for larger machines. And like any tool, no language is good for everything. We have to, so that's why we have multiple languages. Never this idea of a simple language to rule the world never worked. And it's exactly like tools. We have specific tools. You can use the wrong tool for the job. It works, but it's not good. It's not the best experience. So if you want to be a real good programmer, or a real good software engineer, you have to learn to use different languages to choose the best tools for each job. And so now focusing on Lua, as every language has to do trade-offs. How Lua solves its trade-offs. There is a set of explicit goals that we prioritize in the design of Lua. So Lua had that very strong focus on, I will explain them, but scripting, portability, small size, and simplicity. These are the main goals. So most of the time, not always, we have sometimes all the other goals too, but these are the main goals that we always think about when designing Lua. Is about this, is the main concerns we have with the language. We have other goals, as I said, but pragmatism. We are not religious about anything. We do not have those basic principles. Everything is an object or whatever, any rule that we must always follow. And we have some secondary goals like performance, friendliness to non-programmers. This is kind of not necessarily, but may be the result of simplicity. And how does this work in practice? So what those goals means and how do they reflect in the design of Lua? Well, first, scripting. What does it mean, scripting? There is today a lot of people use scripting languages. It's almost the same, it's almost a synonymous for dynamic language, but it shouldn't be. Scripting language, in its original meaning, is the idea that a program is written in two or more than two languages, but the basic idea, you have two languages that are called exactly the scripting language and the system language. This started with the shells in Unix. You have several small programs, the basic idea of Unix. You have several small programs written in C, and you have the shell language that you connect all those programs doing pipes and all kinds of connections between those parts. That was where the idea of scripting originated. And so the system language that typically can be C, C++, or we call it any kind of hard language, where you implement the algorithms, the data structures, and usually these are reasonable stable parts that do not change a lot in your program. once you implement a good data structure, you are not going to change a lot. You don't have to adapt to different users, etc. And the scripting language somehow connects those parts. And this is where the language should be flexible, easy to use. For instance, user interfaces, menus, drawings, etc. should be in this part that it's easy to change, to adapt to different kinds of use. And usually when we talk about scripting, not always, but it's very, not always people recognize this difference, but it's a very important difference in how we use scripting. There is a more traditional script, the original scripting idea that is now called the extending the language. That the idea is that the scripting language is kind of your main language, and the system language is used to write libraries for this scripting language. So it's kind of use the system language to extend your application written in a scripting language. But many applications actually are the other way around. You have what you call embedding. The application itself, I mean the main loop, you can think about where is the main loop of the application. The main loop of the application is in the system language. I mean the application itself is written in C or C++, and it calls the scripting language for some particular tasks. Sometimes this particular task can be huge parts of the program, but who has the control, who has the timing of the application is the systems language. This is common in games, for instance. You have engine, and the engine runs the frames. At each frame, it calls the scripting language to do it. As I said, it can call the scripting language to do all actions of the game, but who has the control of the pace of the program is the system language. And several scripting languages are extremely focused on extending applications. Most languages are not that good in embedding, and Lua, since the beginning, has been written with both kind of uses in mind. It's really good to be used in all those. You don't have to, for instance, Python, it's very frequently people say, oh, if you are doing embedding, you are doing it wrongly, but that's not a general software principle. That's a problem that Python really, it's not good for embedding. So in Python, if you are doing embedding, you are doing it wrongly. But in Lua, you are not. This is a very good strategy for a lot of kinds of software. The other point is portability. And by portability, we mean actually to run in almost any kind of hardware we can think about. Lua even runs inside kernels. For instance, the NetBSD operating system now comes with Lua embedded inside the operating system. You can run Lua scripts without leaving the kernel. And it runs directly on the bare metal. For instance, Node MCU. It's a very small microprocessor that runs Lua without any operating system at all. You just have the hardware, and Lua runs on top of that. So Lua is really portable. It runs almost anything. The only restriction is that you really need some memory. I mean, for instance, you have those really small microprocessors with K bytes of memory. You cannot run Lua, but if you have 1 megabyte of memory, then it's plenty of space too. Size is, of course, if you want to fit Lua inside a microprocessor or even inside an application, you don't want to bloat the application. The scripting language should not be too large. So this is the size of Lua in lines of code. This is the evolution. So this is lines of code. That is logical lines of code. It's more or less you count the number of semicolons in your code. It's more or less an approximation of the number of statements that you have. And then you see you still have less than 25,000 lines of code. This is the whole interpreter with all libraries, etc. This is the whole system is still very small compared with most other scripting languages. Simplicity, it's hard to measure, but as a proxy to simplicity, we can get the reference manual. This is not Lua, the good parts. This is Lua, all the parts. This is the entire of the language. It documents the whole language, the API with C, and all the standard libraries. And this is the spine, I mean, in proportion. This is the spine of the, it has more or less 100 pages, and it documents everything of the language. We joke in Lua, the reference manual, it's really serious. People joke, it's not in the manual, you should not use it, it's not in, shouldn't be in the language. So the document really includes everything that people use in the language. So this is everything you have to learn. Whether you can learn reading that, it's a different story, but if you can learn what it's written here, you should know everything you need to know about Lua. And how Lua achieves this simplicity? It has a few but very powerful mechanisms. Well, for those that know Lua, the main mechanism is associative arrays. That's a kind we call tables in Lua, and we use associative arrays in Lua for everything. Even plain arrays in Lua are associative arrays that associate integers to values. And all kinds of data structures in Lua, maps, arrays, objects, even modules are implemented using tables. We have closures, first-class functions with lexical scoping that works as you expect, with no restrictions, no surprises. You can do plain lambda calculus or functional programming in Lua without any restriction. And we have coroutines. That is also a very powerful mechanism of control for very different kinds of applications. It's a little more complex, but it's very powerful. And how does that work in practice? I mean, how those features translate in the uses of Lua, why Lua is used, where it is used, and what's the connection with these features? Well, for Lua, it's very successful in games. Maybe the area where Lua is most popular. And why Lua it's so popular with games? I mean, this is a description of what this slide actually should be earlier. A description of what I mean by scripting. Exactly, this is a very good description of what is scripting, the idea of scripting. So we have the idea of an engine that is written in C, or typically in games they use C++. And the engine does all the physics, all the graphics, all the hard parts of the game. I mean, the computer-intensive parts of the game is embedded inside the engine. But as the people in games say, the heroes in the development of the game are what they call the scripters, are the game, they call it scripters, sometimes they call the game developer or game designer, is the people that really create the game. Those people typically are not professional programmers. They are specialized in creating games, not in programming. They are not very good or any good at all sometimes in data structures, exactly in graphics, all those algorithms. What they are good is at designing game, thinking about how the game evolves, how are the characters, how they interact, etc., etc. And this, for instance, is a typical kind of embedding. The engine is the main loop. The engine runs the game and calls scripts to move the characters, to do the behavior if object in the game. But a tremendous amount of the game is written in Lua. As I said, only because the main loop is in the system language doesn't mean that the main part of, the larger part of the code is written in the system language, it's written in C++. The larger part of the code is written in Lua outside the engine. And the engine and the Lua interpreter itself, as I said, the Lua being small is good, is a small part of the finished product. So from this slide we can get those, it's embedded here, all those good parts of Lua. As I here is okay. Here, can you hear? Can you hear me in the back? Yeah, okay. So, as I said, first, embeddability. This is a very important in games. Most games are not extending. Most games are not written in Lua. Most games need the engine, and to keep the frame rate of the game, you need to have the engine in control of the main loop. You cannot, oh, I'm going to write the whole game in Lua, or in any other scripting language. Usually it's hard to keep the frame rate. It's much easier if you have the engine keeping the frame rate for you in C or C++, and calling the scripting language as at each frame, or sometimes not always each frame, every X frames. As I said, it's very important to be easy for non-programmers. I mean, when I say non-programmers, it doesn't mean anyone, but I mean non-professional programmers, people that have some experience in programming, but as I said, did not have a solid formation in data structures, algorithms, etc. It's important to have small size. It's very important to be portable. For instance, Grim Fandango now runs, at the time, I think it was made for Windows, I'm not sure, but now it runs on Linux, OS X, PlayStation, Android, iOS, and a lot of different machines, and all of that using Lua. And of course, performance is important. As I said, it's not the main point, because the really heavy parts of the game are written in C++, but it has to have performance to do all the actions, etc., keeping the rate of the game. Another widely area that Lua is, area where Lua is widely used is in real embedded systems. I'm here, embedded is a different meaning. I mean software embedded in hardware. So Lua is being used inside TVs, inside routers, keyboards, car panels, printers, set-top boxes in TVs, calculators, mobile phones, Internet of Things, etc. And why Lua is good for that kind of systems? Why do people use Lua for embedded systems? Again, portability here is a must. Of course, all those hardware are very strange. Hardware completely non-conventional. Many of them doesn't have an operating system or have very restricted operating systems. Small size is important. As I said, Lua is small, but it's not small enough. If you really have very small hardware, like I said, with just a few 100 kbytes of RAM, that's too small for Lua, but is among the smallest that you can find. Often, if you cannot use Lua, you have to use C. It's very hard to use anything else. And people that it's not in embedded system sometimes do not understand that, but it's also very important for scripting. Again, in embedded systems, it's very common that the final programmer is not a professional programmer. It's something that it's doing, it's acting in the domain of that specific piece of hardware. And that kind of embedded systems, they are funny. Sometimes you do something wrong in the software and you can destroy the hardware. If, for instance, if you not set the configuration correctly, you can burn a piece of hardware, etc. And so a scripting language gives you a very good isolation. So for instance, in C, of course, you can do everything. And so it's very, very easy if you do any, I mean, you have a bug. Oh, this is a bug. Oh, I burned my I/O port or anything like that. In Lua, someone professional write a small library for you. You can only access the ports through the library, and then the library can ensure that everything is correct. And because exactly Lua is designed to be used in that way, you cannot do anything wrong. You cannot access the hardware directly without using the library, so you cannot do anything very stupid with your hardware. So even if you try, you cannot burn parts of, you cannot misconfigure parts of your hardware. And as I said, it's easier for non-programmers. Sometimes the people doing the final adjustments, doing for instance, doing a panel, they want to do good images, etc. And again, that people are not professional programmers, so it's good that the language is easy for them to use. And finally, of course, another area that Lua it's used is in, I call it real scripting of applications, where you have a big software, a kind of more conventional software running on more conventional machines, and you use Lua for what we call end-user programming. So for instance, Lua, it's used inside Wikipedia. When you write Wikipedia pages, you can put some Lua programs to perform some tasks. Lua is used in Wireshark, in Nmap, that is a network explorer software. In Lua Tech, the new version of LaTeX, you can use Lua embedded in commands to do all those text formatting, etc., instead of using Tech as a programming language. I don't know if anyone here have experience programming in Tech, not writing Tech formats, but writing real loops and functions in Tech is a nightmare. And so Lua is being used in a lot of different applications. And again, why use Lua in those applications? Of course, scripting is the main point that we need for that kind of thing. Most of those users are extending, but some of them are embedding. But anyway, it's very important to have these capabilities of scripting. Size, again, it's always important, and easy for non-programmers. It's very important. Again, that's for end-user programming that almost by definition are not professional programmers. So a language with a nice syntax with arrays starting with ones, that like most people that are not programmers think lists, etc. It's a nice thing to have. And then why not use Lua? So there are some very good reasons for not using Lua. Of course, when there are better options, whenever I will not give you the better options, but I will not promote other languages. But of course, if you see, oh, I have Lua, I have this other language, and for what I have to do, this other language is better, of course, do use the other language, please. As I said, I do not believe Lua that's language for everything. I do not believe any language is the best language for everything. As I said several times, Lua, if you read, you should not use Lua. And this is both large and small. I mean, small, I mean small memory. As I said, you cannot fit Lua or any interpreter language in maybe fourth. Some people sometimes use fourth, I have to recognize that, for real small systems. But sometimes you have real large systems, but you have to be very efficient with the use of memory. And then again, Lua or any other very high level language will not be very good. For instance, if you have garbage collection, you're already wasting some memory. That is a fact about garbage collection. And Lua and several other languages have few data types. For instance, you have only one type of integer, one type of double precision. And for this application, it's essential that I use single precision floating point, because then I use half the memory. I mean, everything in my memory are floating point numbers. I don't need double precision, so if I use single precision, I have, of course, twice the memory. And if the language doesn't offer you the option between double precision and single precision, this is a big loss for that kind of application. And because of garbage collection and a lot of other things of higher level languages, we do not have a direct control over memory use. For that, you really have to use C or C++, a really low-level language, if you really have to control every byte, everything in the memory you are using. Of course, you should never use Lua for hard real-time systems. Once I heard a creator of a scripting language saying he would be feel safe flying a plane controlled by his language, and I said, this guy's crazy. I would never enter a plane that yes, exactly. So again, we do not have direct control over the CPU. What the CPU, unlike again very low-level languages like C, where each operation, this is, almost exactly what the CPU is doing in each instruction. Some examples in Lua and in many other higher level languages, you have garbage collection, you have rehashing, you use a lot of hashes and that kind of stuff. Even in Java, if you do not know very well the libraries you are using, you have the same problems. You get, this is a very good data structure, but if you not know exactly how it performs, you have exactly the same problems. And sometimes, of course, if you want to do some quick and dirty programs and you need a specific library and you don't have that library available, of course, you are not going to develop a new library just for your quick and dirty applications. And to finish, I'd like to some bad reasons for not using Lua, but frequently people do not use Lua because of these bad reasons. One is just nitpicking. And I refuse to use Lua because it doesn't continue, or I refuse to use Lua because it indexes arrays from 1. And as I say, for end-user programmers, this is much easier. And as I say, for real programmers, it should be easy too. I mean, programmers should be for them it should be much easier to adapt to 0 or 1 based arrays than for non-professional programmers to adapt to 0 based arrays that they never saw in their lives. Hard to find programmers is, I'm not going to use Lua because I cannot hire people that know Lua. I mean, it's very easy to learn. I can assure you, unless you are doing some really quick and dirty programs that you need everything ready in 1 month, in a few weeks, I'm sure your non-Lua programmer will be a better Lua programmer than your whatever other language programmer that supposedly knew the other language, but actually didn't knew it right. I mean, only knew the good parts or only knew some small parts of the language. And you really can learn the whole language after a few weeks. And missing libraries, again, most often you have these libraries written in C or in another language, and it's not a big effort. Again, if you're doing some quick and dirty really fast, then it is a big effort, but it's a really doing a larger project. It's not a big investment to spend 1 week. Sometimes it's more than enough to write not the library itself, but the binding of that library to Lua. And then you have that the library that I don't have that library. It's very easy to adapt and write a binding. So that's what I have to say. The main points, as I said, I think one of the main points that people forget is that language design always involves trade-offs. You have to choose something over something else. You have to sacrifice something to get something. And those trade-offs are done either consciously or unconsciously. A lot of people just do the trade-offs without thinking about them, and they can only see the good parts of their languages, but they do not see what they are leaving out. No language is good for everything. And again, as I said in the beginning, for real software engineers, you have to use different languages. Most large software projects involve several different languages. It's very common for a project to have 4 or 5 different, you have one language in the browser, one in the server, another in the database part, and etc. And Lua, it's very explicit about its set of goals. It's a language is very, very defined, strong, good parts and also bad parts, of course. And to finish, I love this illustration of by compromises. That's questions? Or?
Thank you, Roberto. Everyone, please wait until you have the mic. Just a second. So,
Hi. I don't. Do I hear my? Yeah.
Yeah.
Well, you haven't told about sandboxing at all today, and it is a very powerful feature. But usually it ends in just doing the whole sandboxing stuff at embedding level. You embed, you restrict it all the way you need, and it is enough. But when the actually lower level sandboxing, when you create a new environment table and apply it, really is applied in real world. I'm really wondering to hear about cases where it is used.
I'm afraid I do not understand what's the question. It's
where sandboxing is actually used, where it's beyond embedding level. When you embed, you actually buy things at C. But when you sandbox using Lua, when you create empty table and use setEnv function. Yeah.
Oh, low-level sandboxing. Yeah, but
I mean,
When is it really used? In which situation? Some real examples.
of embedding, of sandboxing. Well, I have one nice example that once I gave a talk about Lua in a Python conference. And I had a slide about this scripting, this idea of scripting, and I had a list of languages where Lua had been used for scripting. And Python was not in the list, and seems obvious. Why would someone want to script Python? And then someone in the audience stood up and said, you should put Python in the list, because we have a very big Python application in finance, financial application written in Python, and they wanted to give to the end user a kind of a prompt so she could write scripts. I mean, she could call functions and do that kind of computations, but the end user shouldn't be able to change the behavior of the application, I mean, to break the rules, etc., of the application. And so it needed that kind of isolation, and Python cannot provide you that. Cannot, for instance, give you a console where you cannot call some functions or you cannot see some modules, etc., etc. And so they embedded Lua inside their Python application and gave Lua as the script. So you can write scripting in Lua, and then, of course, that it's easier because it's not real isolation between Lua and Lua. It's an isolation between Lua and Python, but that's the kind of idea of isolation. Another example, real example, is World of Warcraft. World of Warcraft, the game, you know, the World of Warcraft offers Lua for end users. You can write, there is a huge community of Lua users in Lua, World of Warcraft, with huge selection of libraries. They have the Traveler Salesman implementation, for instance, so you can visit a map, a lot of places in a map where you have been. And they have in the rules of the game that if you use C, for instance, to send invalid stuff to the server, you can be eliminated of the game, you can be outed of the game, but everything you do in Lua, it's valid because they ensure that the Lua they offer you, it's sandboxed enough that anything you do in Lua, it's valid, it's not an exploit, it's valid to be done.
Okay, thank you.
Okay, guys, we're a bit short on time. Roberto will have another talk today, and he will be on the round table in the evening. But so please, only quick questions, so everyone has a chance. Roberto, quick answers, please. Okay. Sorry about that.
Yes. No.
It's a very interesting picture. We've got, we argued with my colleagues about dynamic typing and static typing, and the question concerning Lua is the following. I want to ask you about function argument types. Do you think it's a good idea to check argument types at the beginning of each function? Some people say we should do it in all functions. Some people say we should do it only in public APIs function, and some people say we don't need it at all. What do you think?
I think it's a case-by-case scenario. I'm not sure everybody saw this picture with enough attention that the result of dynamic typing is I mean,
yeah, it looks neat, but if you look closer, something is wrong.
So it's a done that, and that, but that's exactly, it's a quality. But I mean, if it's good enough for audio, you have to do. And if you really need to type everything, you shouldn't be using Lua, as I said. The point is just get a strongly typed language. It's much better for you.
Okay, thank you.
I say, if I may add, in my personal experience, 80% functions you have to check if it is nil, it should not be. Public APIs, check for types, don't care about the rest. Next question, please.
Hello, I have a simple question. Why tables index starts with 1?
Sorry, why tables?
Table index starts with 1.
With 1?
Not with.
As I said, because
0.
it's much easier. When we started, our main users were Fortran programmers. Fortran uses one. And they were not professional programmers. They were mainly geologists, civil engineers, etc. And you can imagine that mathematics use one from indexing. If you get any book of matrices, etc., that it's from mathematical people, not from programmers. Tables start, matrices start with A11, A12, etc. So it's unbelievable more natural. Can I give a longer?
Roberto, no.
Okay.
Next question, please. You will be able to give it at coffee.
I have another question about design. Why never objects of different type are equal? Why can't you overload IC method to compare objects of different type?
We should need a different equal. All languages that offers something like that have to offer a kind of raw equal. And then, for instance, our inspiration always was Scheme. Scheme has like 4 or 5 different equals. And that's a nightmare. So we stopped with one, and it's the one is the raw equal, and that's
Do you want triple equal sign in Lua? Come
yeah,
on.
triple or 4 equals or equivalent and similar and equal. It's a very tricky business.
Thank you.
Last question, Mike, please. Okay. Go.
No, I just want to extend these questions. Is it possible, create new fallacy values by user data, for example?
Yeah, it's the same point. Again, we would need some different. Maybe one of the main reasons was in the beginning that there was nothing of that. When we added that, then a lot of internal parts of Lua depends on, for instance, even to check types, you depend on equality. And if you can do something different to be equal to something else, then you can break a lot of internal security code that checks. So you would break a lot of stuff if you added this.
Yeah, I just mean it's fallacy in.
Yeah, but it's the same. The same idea is the
context,
result is something that is this nil. Yes, but it's not kind of.
Something like absent value in functions. Yeah.
Yeah, it could be done.
Okay.